Precast concrete is manufactured off-site in a controlled environment. This helps minimize negative impact to a construction site while maximizing quality. Precast concrete does not require on-site storage or staging and is delivered to the project as it is needed. It is typically erected with a crane and a relatively small crew, which allows for construction within a tight perimeter of a project. This can greatly decrease the footprint requirements of a project site and help minimize disruption to the surrounding areas. Precast concrete also arrives to a project ready for installation and typically does not require additional cutting or modification, thereby reducing dust and waste. Many projects have used the inherent strength and flexibility of precast concrete to help reduce the heat island effects by creating green roofs, consolidating parking, and using lighter colors. Because it is made of concrete, precast has thermal mass, which can be used to reduce the total energy needed to heat and cool a building. Concrete has a high heat capacity, which means it can slowly absorb and store heat energy, and likewise slowly release it when the temperature differential shifts. This helps reduce the magnitude of the heating and cooling peaks, as well as shift peaks to times when utility rates are less expensive. This all translates to less energy needed to maintain a comfortable and more uniform indoor temperature. Precast concrete sandwich wall panels combine thermal mass with a layer of continuous insulation, thereby eliminating thermal bridges or cold spots. This has been verified using thermal imaging. The effects of thermal mass can also be seen in the thermal imaging studies. Since energy efficiency is one of the greatest factors contributing to the total environmental impact, this is a vital area to optimize. Precast concrete sandwich wall panels can greatly contribute to the optimization of a building's envelope and can help reduce the total energy consumption of a building by as much as 30%. Precast concrete is a regionally available material, with PCI certified precast concrete manufacturers in almost every state. Getting materials within a 500-mile radius is easy. Precast concrete often contains recycled materials, such as supplementary cementing materials as a replacement for cement and recycled steel used for reinforcement and hardware. Precast concrete is also fairly unique in that it can be disassembled and reused in another project. This has already happened on several projects. An example is one of the stadiums used in the 1996 Olympics in Atlanta, Georgia, where the stadium was disassembled after the Olympics and used to create 4 high school stadiums. Precast concrete is an inert material and does not contribute to poor indoor air quality. Furthermore, since precast concrete can be erected quickly, buildings are enclosed faster, providing a barrier between outside contaminants and moisture, while shaving months off a project schedule. In many cases, precast concrete can be left exposed on the interior of a building, eliminating the need for drywall, reducing waste, and increasing the overall durability of the interior finish. Precast concrete also does not provide a food source for mold, thereby helping to improve indoor air quality. Precast concrete provides flexibility in design. Designers and precasters work together to come up with innovative ways to be more sustainable. An example of this is the Cancer Genetics Research Center at the University of Florida, Gainesville. This project used thin brick veneer cast into precast concrete wall panels instead of traditional hand-laid brick. This decision saved over 1,150 tons of mined clay, which is enough clay to clad over 4 other similarly sized buildings. It also saved over 12,600 gallons of diesel fuel that would have been used to transport the full-size brick, and shaved almost $69,000 in material costs. Ultimately, the owners and designers were able to preserve the look and feel of the building while utilizing a more sustainable solution. Concrete is very durable and has been around for hundreds of years. Precast concrete does not combust, rot, or rust. In fact, precast concrete can be designed for a 100-year service life or more. The Precast Prestressed Concrete Institute conducts research in conjunction with universities, government agencies, and other organizations such as the Charles Pankow Foundation in order to improve the design of precast concrete structures. Some examples of this research include the Seismic Program, which has been done on wall and framing systems and more recently diaphragms, with the DSDM or Diaphragm Seismic Design Methodology Program.
The precast concrete structures industry has always been a leader in design and technology, and we've done that by conquering any barriers that we've encountered to using our precast concrete building systems. And for a long time, nobody would consider building a precast concrete structure in a seismic zone like California. With our PRESS program, we started breaking down those barriers, and now we're going for the gold. It's not good enough that precast concrete is okay to use in a seismic zone. Okay, we want it to be the best system to use. And in fact, this demonstration and this whole project is really advancing us more in that direction, where precast concrete systems are the best systems to use in seismic areas, as opposed to what used to be not recommended system.
Precast concrete structures can be built to not only withstand everyday loads and forces, but their inherent strength and properties also provide longevity.